Have you ever been researching a galaxy on one of the NASA databases or on Wikipedia, and you saw under its galaxy classification that you've just got a bunch of letters and numbers, and some of the letters are capital, some of them are lowercase, some of them have brackets, and you're like, what on earth is all of this? Don't worry, I was there, and now I understand galaxy classification. I'm here to teach you about it. Hi, I'm Seti. I'm a PhD student studying the Milky Way and I guess galaxies in general. So I find this stuff very interesting and very important to my own research. Today I want to give you a really useful resource on how to decode these interesting letters and numbers and brackets and interesting symbols. The current way that we classify galaxies is using the Vaucouleurs system, which has been slightly refined since its creation by Vaucouleurs many decades ago. I think it was in the 1960s. And it's mainly based on the morphology of the galaxy, so how it looks to us, the observers on Earth. This can mean that the galaxy classification system can be a little bit more on the subjective side and somewhat dependent on sort of the images that we have of a galaxy, so how well we can view it. The structure of this video is going to be a little bit different compared to some of my other videos. Instead, we're going to try and approach this through, I guess, a more sort of diagnostic flowchart kind of structure. And so that way, if you have a galaxy that you want to try and have a go at classifying yourself, you can go through this video in its natural order and you'll be able to sort of build up your own classification of it on your own and compare it to, say, the official classification that it has. So there are 4 parent categories that we need to focus on. That is ellipticals, spirals, lenticulars, and irregulars. We're going to start off with ellipticals first because it is super simple and super easy, and then we're going to move on to spirals, lenticulars, then irregulars at the end, where it gets a little bit more complex and there's a couple more sort of additional stuff that we need to focus on. Ellipticals are quite simple. If you notice that the galaxy is quite round and yellowish, sort of like a little, I guess, a rugby ball, or sometimes it's even a sphere, we can denote it by the capital letter E, which of course stands for elliptical. Following that, we've only got one other subcomponent of its classification that we need to worry about, and that is whether it is face on from us, so its orientation with respect to us on Earth is face on, or if it is viewed edge on. And if it's face on, we give it the number 1. And then if it's edge on, we give it the number 7. And if it's somewhere in between there, we'll give it a number between 2 to 6. And that's kind of it for ellipticals. It's that simple, just 2 things, letter E and then a number. That's how simple it is. Spirals, not so much. We first need to ask ourselves whether the spiral has a bar or not. And if it doesn't have a bar, we give it the capital letters SA as its main classification component. If it has a bar, we give it capital letters SB, with the B of course denoting that it has a bar. And if we don't know, or if it's sort of iffy whether it does or doesn't, then we give it the SAB classification. The second question we need to ask is how tightly wound the spirals are. If they're very tightly wound, we add on the lowercase letter a after the capital letters, and then if it's very loosely defined, we give it the lowercase letter d, and then we have loads of subgroups in between that depending on if it's like somewhat loose, somewhat tightly wound. So we go from A, AB, B, BC, C, CD, and then D. So there are some intermediary subcomponents as well, so that just adds a lot of complexity to it. It is quite useful. Following on from this, if you find that the spiral arms aren't necessarily regular in their structure, so you can't really make a solid conclusion as to how tightly wound they are, instead we give it the subclassification, the lowercase letter m. The third question we need to ask is where the spiral arms terminate. If they go all the way to the center of a galaxy, we give it the bracketed lowercase s letter, with center beginning with the letter S, of course. I'm not sure why it is an S. I would have expected it to be a C, but I don't know, that's how it is. If they terminate within the inner ring of a spiral galaxy, we give it the bracketed lowercase r, and if they terminate within the outer ring of a galaxy, we give it a bracketed capital R. If it has a more transitional ring structure, we give it the bracketed capital RS. The final question we need to ask is how defined these spirals are. So how crisp are they? Can you really see where the spirals are and where the sort of the big gaps between the spirals are? And this is denoted by Roman numerals, actually, with the letter or number 1 or letter I being very well-defined spiral arms, and then the letter 5, number 5 and letter V being denoting very loosely defined sort of, I guess, yeah, very loose undefined spiral arms. And that is basically it for spirals. We've got quite a lot of little components. So we've got whether there is a bar, how tightly wound the spirals are, where the spirals terminate, and then also how defined are the spirals as well. So there's quite a lot of interesting components. A typical spiral definition or classification might have all 4 of these. 1, 2, 3, 4, I think there were 4, or they might only have 3 of these, depending on, you know, what is necessary and what isn't. The third type that we need to consider are lenticulars. These are usually a mix between ellipticals and spirals, and some of them are quite gas poor as well, so they don't even form very well, they don't really form spirals. They can just be plain exponential disks, so they can be a little bit of a mishmash between the 2 subcategories. So classifying them has always been a little bit more difficult compared to the other 2. So I'm going to try and explain this as best as I can using the most up-to-date system that I've seen so far, although I've noticed what people define as certain numbers and stuff can vary quite wildly, so I'm going to give this my best shot. The first question we need to ask is whether there is a bar or not. If there isn't a bar, we just give it a capital letter S and a 0 classification, so S0. And then from there on, we need to ask the question, how much dust is there within the lenticular galaxy? If there is a lot of dust, we give it a subscript 3, so that's S0 subscript 3. If there is very little dust, we give it S0 subscript 1, and if it's in between, it's 2. If it does have a bar, instead of giving it an S0 classification, we denote it with an SB0, with the B, of course, meaning that there is a bar. And from there on, the subscripts actually don't tell us the amount of dust within the galaxy. Instead, they're used to tell us whether the bar is very prominent or not, with SB01 telling us that it has a very weak bar, SB02 telling us it has a sort of semi-weak bar, and then with SB03 telling us that the bar is very strong. I have seen this sort of being mixed around a little bit, so the subscripts with the barred type, the barred lenticulars, also meaning dust prominence, so it can be a little bit confusing, but I think what I've just said is the correct way of classifying them. The final and most annoying category, in my opinion, are the irregulars. So these are galaxies where, by process of elimination, you can definitively say that they are not ellipticals, they are not spirals, and they are not lenticulars. These then get put into the irregular category. Now, despite me saying by process of elimination it's not a spiral, the first question we need to ask about an irregular galaxy is, are there any spirals, and is there a bar? And if there are no spirals, no bar, we give it either the capital letter I, the capital letters IA, or the capital letter S with a lowercase d classification. Yes, there are quite a lot of ways to define irregulars. If there are both spirals and a bar, we give it an IB lowercase d, and then or a SB lowercase d classification. And if you're not sure, it's either IAB lowercase d or SAB lowercase d. So it kind of follows a similar pattern to the spirals, with a couple different changes. The second question we need to ask is, where do the spiral arms terminate? And this is exactly the same for the spiral galaxy classification. If they terminate at the center, it's a bracketed S lowercase. If they terminate within the inner ring, it's a bracketed R. lowercase again, and if it's within the outer ring, it's a bracketed capital R, and you also have the capital RS denoting a transitional ring structure. Next up, is there a central bulge? If there is a central bulge, you don't change anything with what you've just done. That's your classification all wrapped up. You can just go ahead and yeah, that's it done. If there isn't a bulge, you change the lowercase d in that the first step of the classification to a lowercase m. And if you can't tell, or if the galaxy is so irregular that you can't tell that there are even spirals, a bar, or if there's any sort of ring structure at all, then you skip all of this entirely and just give it the classification IRR, so capital I and then 2 lowercase r's, denoting that it is completely irregular. If it is Magellanic in its type, we sometimes also call it an I lowercase m, telling us that it is irregular, and also Magellanic in its type. But from there on, that is pretty much it for the Vaucouleurs classification system. It is very complex. Some of it can be a little bit unusual as to why we've chosen to sort of ask this question surrounding the galaxy and why we haven't focused on any other aspects. But yeah, that is kind of the standard way of doing things. And if I'm going to be honest with you, we don't really use these classification systems that much. Or we don't really hold it to such a high sort of standard. Instead, we sort of focus on a more holistic view of a galaxy or a group of galaxies that we want to focus on. So don't get worked up about it too much, but it is kind of useful to know about it and understand what these little symbols mean. So that's all for galaxy classification. It can be very complex, I understand that, but I hope that this has been at least some part helpful to you in either you wanting to understand what all of the symbols mean, or if you want to have a go at trying to classify a galaxy yourself. And with that, I will see you in the next video.